Hi math friends, we're talking about measures of variation today. We're going to go over a few terms: quartiles, the interquartile range, and outliers. We're going to be talking about these throughout the video, so please refer back to your notes and write in those definitions as we go along. A very simple definition of quartiles is that if we split up all of our data into 4 parts, we would have quarters or quartiles. So using a very simple chart here with money, I chose easy numbers for us to use: 25, 50, 75, and 100. The first thing you have to do is write them in numerical order, just like we did when we found median and mode, and say, where is our median? Remember, our median is right in the middle. So right here, our median is halfway between 50 and 75. Our first quartile is going to be halfway between the data that's to the left, or that's lower than the median. So our quartile 1 would be between 25 and 50 here. Our third quartile is going to be halfway between the data that's higher than the median. So for this example, it would be halfway between 75 and 100. We're going to look at an example where we actually compute some values now. Looking at animal data. Please fill this in while we go along. There's a lot of new information here, and we need to go through this step by step. So we're looking at animals and the speeds that they run in miles per hour. Some of these are real fast, some are real slow. Our range for this, well, we just said before we start we should put them in numerical order. So let's start. Looks like these are in reverse numerical order from top to bottom. Let's just write them out. To find our range, not interquartile range, but just range, that means how far is it from our highest data value to our lowest data value. So in this, for example, it would be from 70 to 1. And that would be 69. You just subtract those. Our median here, let's find what number is in the middle. Instead of crossing out, I'm going to underline. You can cross out or box in or circle, whatever works the best for you. So let's take the lowest and highest, lowest, highest, lowest, highest. So our median, remember, would be right in the middle here. And to get the median here, we would have to take the average of 30 plus 25, and we would get 27.5. This number isn't actually in our data, but remember that is our median. So our median is 27.5 or 27.5. Quartile 1, we're going to look right at our median and go to the left or go lower than our median. And we're going to go ahead and take the lowest and highest values out, and the number right in the middle, that's our quartile 1. 8. Our quartile 3, we're going to go to the other side, go higher. Take off your lowest and highest. The number that's right in the middle there, the 50. 50 is our quartile 3. Interquartile range, we're going to subtract quartile 1 and quartile 3. So 50 minus 8 is our interquartile range. Sometimes ranges are just listed as the numbers 70 minus 1 or 50 minus 8. But for this, we're also going to find what's that difference. So our range would be 42. We're going to be using the same exact data and talking about how to use all of this information to look for outliers in our data. Using the same information here, quartile 1 is 8, quartile 3 is 50, our interquartile range is 42. To find where our outliers might be, we're going to use this equation here. Outlier range is interquartile range times 1.5. So we have 42 times 1.5, and that would give us 63. Outliers are numbers that are so far beyond our data that maybe they're exceptions, maybe they don't count, maybe there was some sort of accident that happened during our data when we were recording it, Or maybe they're just fantastic amounts that we really can't explain. We just have to actually see them happen in real life. To find if we have outliers, we're going to use our number right here that we multiplied by 1.5. So we have 63. And we're going to check. We're going to do 8, our quartile 1 is 8, subtract 63. When we do this, we get negative 55. What we're going to do is go back to our data and say, were there any animals that were running at negative 55 miles per hour? Well, realistically, that doesn't make sense, but sometimes with our data, if we're dealing with things besides speed, maybe if we're dealing with money, we'll have numbers that are negatives. We didn't have any negative numbers, so no, there weren't any outliers on the low side. Let's see if there's any outliers on the high end, though. Quartile 3 plus our IQR times 1.5. So we're going to add 63. When we do that, we get 113. Were there any animals that ran 113 miles an hour in our data? Our highest was that cheetah that ran 70 miles an hour. So no. So for this specific example, we would say that there's no outliers.